Hey, what's going on YouTube, and welcome back to another video. Today we'll be learning about scientific discoveries and we're going to be learning how rainbows form and probably some others. So if you don't know how rainbows form, I'll show you. So it's some light and rain or small parts of rain, and when we do that, look, it's a rainbow. But unless if something happens, like let's just say, let's do this, or hold on. You know science is how whoa. Now look what it is. It's a rainbow. So, but unless if we kind of change it a little bit grayer, look, this thing becomes darker. Or unless if we change the color, it'll only be red and orange. Yep, all the other colors. And not only that, we're gonna learn how parts move in physics. So let's just get the ball, and we're gonna get something that is like probably like this block. And what will roll? Let's see what will roll first, because his something will happen to one of these. And what will roll? The square or the ball? If you pick the ball, you are correct. Look, see, it's going down, and this one's not. But unless if we turn down the friction, see, it's kind of moving. But unless if we just do, they'll both be sliding at the same rate, or they might slide differently depending on the mass and density. Let's just correct this. So you see how in the phone numbers it says 911? Well, I think I have one theory that suggests how that number came from. So you remember the 9/11 thing, like how the plane, you saw it on the videos that I posted, but this is how so 9/11, I'm assuming that was from like that was from the year 2001, and it was a long time ago, but here's what it looks like. Okay, please forgive me for my building, but here's what it looks like. See, pretend these are the Twin Towers. Let's just fix that, because they didn't look like that. Here it is. Now, let's just say there's a plane like this. I know it's terrible, but that's the only thing I can do. So, here's what happened here's what's like when the plane went like so fast that it crashed in and destroyed the building. Do this. I'm trying to be realistic, so forgive me. So when we put it right here, it's not moving yet, but when we turn up this, it will. Look, it's moving. It's gonna hit it. Boom! Now let's remove that. And here's what is gonna happen to the Twin Towers. It'll knock down soon. Now here's what happens when it's knocked down. See? And it fell down. Oh, and then let's check on something, how we can move stuff. So let's just say we got this ball, for example, and how are we gonna move it? Easy enough. If you pick that, you have to get something to like push it, it moves, and that requires energy to the power of, okay, I'm bad at math, but the more dense this is, the more this is gonna move faster. And unless if we do this, the ball will move really fast. Or unless if we have rockets, for example, and look, it's rolling. Now it's gonna go really fast. See, it's going like super fast. Probably probably about the same as Sonic the Hedgehog speed, 700 miles per hour. But now let's do this. Let's pretend that's Earth and this is our moon. And let's let them separate so it doesn't ruin it. But pretend this is Earth and pretend this okay, let's make the moon like that so it can be a little bit more realistic. And this is the moon right here. So it has the 1/3 of Earth's gravity. So you are on the darn it. So you're on the planet Earth, and if you were standing on Earth right now, this is how it would be when you're standing on it. See, it's like easy. I'll get my color boy. Let's get color boy out and say, let's hear him. Let's see what will happen to him when he's standing on Earth. All right, here he is. Now let's see what happens. Hey, I'm on Earth. Yep, he's on Earth. Now, can you please don't talk for the rest of the video? Okay, I will not. So when gravity pulls him down, it's because of mass and density. So if well, let's just say Earth's density was like less. So here's what will happen. So you see this? It pulled him down pretty fast when he like let him up. Now let's turn it down to like probably like the 1% attraction. See, he was jumping less. So, or if we turn this up by 100% and we let him jump, you can see a big difference for that. So let's just put it back to normal. 10. Now it's a normal mass and gravitational pull. Now let's move on to the moon. Now you'll be thinking, hey, is the moon a lot more? Does the moon have less gravity than Earth? And the answer to that is correct. It doesn't matter. Alright, it matters about the density of one object. So if Earth was lower gravity, we might be able to fall off of it. But since we have a thing called mass and gravity, it just pulls us to the Earth's center, but we don't sink because of density. Now let's just say, darn it. Now let's just say, let's just make this moon maybe like let me just hold on. Now let's just make this a little bit, probably like maybe 5%. Now let's see what will happen if we were jumping on the moon. Yep, you can see a big difference in that. But now let's see what will bring it to it first. Let's see what happens. Earth is attracting this little guy right here, but now let's just attract it to the moon. Now it's not that bad. It's not that good, but it's okay. Hey, now let's just let's get a car. Now let's just make this car let's just make the car like this. It's a terrible car, but whatever. And let's make it work. So because it's awesome. I'll make the wheels a bit smaller so they can make sense. Not pink. Don't make them pink. No, that's good enough. Now, when we turn this on, it's gonna go up. Now, Look, it's circling around Earth. Now, will the car fall? Incorrect, because of gravity. So you see this? Look at Earth's gravity. So if we turn it down, it would have fall. But if we turn it up too high, the car will not fall. But it might go a little bit slower than usual. So let's make that normal. See, now when it's rotating it's perfect. Now, unless if we bring the car over to the moon, let's see what happens to the car. See, look. It's going a little bit faster when it's going at the bottom. See, uh-oh. That's not good. Let's turn that up. Alright. Let's make this other real 160. 160? Look at this little car. It was trying to get up the moon, but fell on to there. But now let's just add some ocean. Let's add oceans on Earth and pretend this is the ocean. Now let's do that. And look, it's bringing the water to it. But now if we do this, it's not that powerful. It has to do with the gravitational pull. At least we made the car unstoppable. But now, let's see what will happen when it's orbiting Earth. So let's just make this orbit. See, this is what will happen. I'm sorry, bye. But this is what will happen if Earth was, or if the moon was rotating Earth. See? Hold on. Now, up to that. No, don't fly away. See? See it? Now, oh, we just flung it away. No, we can't do that, alright? Or, no, let's make this a little, oh no. Okay, that was actually kind of funny. Let's turn it up. Now let's speed it up. Look, the moon's rotating the Earth. Saw that? Now let's remove these, and now let's talk about how light heat works. Let's talk about how lasers cut through stuff. So you see this laser? This one's a normal laser. So let's just say, let's get a ball. See, it doesn't cut it because it's a laser pointer. But now, if we make it a cutter, it would have been bad. Like, let's see what happens when we put this ball in this. See, it cut it in half. Now we have to understand that because of so fast light. So the light is really fast, and if a ball was traveling at you like the speed of light, it would have cut through you easily. Because lasers are also a main source of light. The reason that we're not getting cut by them because they're really small. But let's just say this laser has been because there's more molecules and the light is a lot more bigger than usual. Now if we put a ball there, it will cut easily. But now let's do this. Let's just cut these apart. See, it's because of lasers. But no, now we're gonna talk about liquids. And why do liquids matter? Get it? Matter. Okay, I'm bad at jokes, but let's make a pool of water. Do this now. Boop, boop, boop. Do this. Now, look at this. Look at the water. Now let's add a boat. like a really terrible boat, but look, it's sunk. Do you know why? It depends on the materials. It determines about the mass and density. So if we do this, the wood is a lot more less dense. Now, if we just make this a metal, it would have sunk. If you don't believe me, let's try that. Or steel, that works. And let's make it glass, rubber, steel, stone, wood, helium. See? Look at the helium. Let's just make this. Look, it's floating away. But don't worry, I'll make it come back. Gold. Yep, it sunk completely. Now, let's make this a wood again. So, let's see what will happen if we change its density. So this is terrible density and less density. See how the boat is floating? Because of densities is lower than the water, so it will just hover like a normal sailboat. So let's add a rocket. See, it's moving. That's a really fast rocket, and it's not gonna just keep on going forever. I'm gonna slow it down because I don't want it to fly away. Now look, see? The boat's moving because of energy and density. Now, let's just make this ball fall. Will it make a humongous splash? I mean. Let's see. Yep, it made a splash. Now, let's make it a little bit smaller, a little bit bigger. Now, let's make these walls bigger so it doesn't do anything bad. Now, let's double this again. Or do this. Okay, let's just do this. Now, you see this? Now, let's make this ball fall in. See, it made a splash. Now, unless we do this, see, it made that. Now, you want to see a wave? Okay. Now, let's just see what will happen if we make this really good. Now, let's drop this in. And let's do this. Then let's change the mass or make this rise. Now see, it's rising. It made a wave because of friction. Now let's turn this all the way up. See what will happen. See, it's like clumping together. Do you know why? Because of friction. It's like they're crawling. Now if we turn it down a lot, it'll just scatter away. So why does it happen? Well, who knows? But now let's see gears. No, I want this to be this. 20 gears. Now let's make this 14 gears. And what will rotate it? The bigger gear. See it? Look what's happening. Look what it's doing. Now, let's make this laser pointer doing this. Now, look. It's epic, right? Now, let's make this. And let's make this, kind of low. And let's make this guy dark. And look what will happen. And when this is white, look what's gonna do. Maybe I'll just slow it down. Look what I made. Now, Oh, science, it's almost over for now. But let's do this. Look how it was moving. Now look at it now. So it's almost over now, but let's do one more thing. Now let's do a black hole. Let's make this a black hole. So, well, the truth is, black holes aren't a hole in space. It's just dark matter that's under bad pressure. Now, and this is 100 times powerful than our Earth. So, look at this ball, for example. It's rolling towards the black hole. Unless if we rise it up, now look what's gonna happen. Or, look, it's attracting everything. So let's add these. Look what's happening to it. Now let's make this liquid. Now look what's happening. You are saying that's awesome, right? Well, it is. But look what's happening to all the stuff. To be honest, black holes are time-bending space, but they're impossible to escape. Now, if we get a human, hold on. Okay, but now if we get a human and let's make him spongy, let's see the results. What will happen? Look, okay, let's remove that. Now, since he's flexible, look what's happening to him. He's getting stretched out like spaghetti. And pretty funny as well. Look, he's stretching out like spaghetti because of Hawking radiation. So if we and look, it destroyed everything. That's all for the science. Now I hope you like this, and I might do more if I want to, or if I get more likes and subscribers. Now, goodbye, and see you tomorrow, or if you give me more likes and subscribes. Bye!